Cool. Thank you, Lucy. So yeah, I'm just going to give an introduction into quality assurance on heat networks. So first, I'll give an overview of kind of the market, kind of market context, industry context, updates to legislation and kind of codes of practice, and then we'll dive a little bit more into kind of on a project level, what does quality assurance of heat networks actually look like? So firstly, a bit of an overview of FairHeat. We're a specialist heat network consultancy, and we focus exclusively on heat network quality assurance. So far we've worked on about 200 heat networks, and that number's growing all the time. We kind of work on heat networks all the way from inception and energy strategy stage through the kind of the design, construction, commissioning, and then all the way into kind of operation, maintenance, and then recently as well, kind of looking at kind of retrofits and refurbishment of schemes reaching the end of their life. And kind of the main aims are kind of on new build, we're looking to improve specification, design, and deliver networks that are high performing, high efficiency, and then on the operation side, we're looking to kind of manage that performance, hopefully improve it, and then kind of also kind of minimizing risk throughout all the processes as well. So moving on to the kind of industry context. So I'm sure, as you'll all know, the CP1's had an update recently, which was released at the start of this year. There have been quite a few events and kind of talks around that already, so I won't we won't spend too long on it. But I think the key takeaways for this is that the minimum best practice kind of technical requirements have been, they're far more wider reaching and they're far more thorough. They're also much better defined performance metrics, and that is important in this context because a lot of those are kind of starting to feed into contractual requirements. And also on top of that, there is a much greater focus on assurance throughout the document, and kind of meaning that throughout all stages of heat networks. And kind of as an example of that, as part of the update to CP1, there's been a design checklist, kind of a compliance checklist released of example of which is shown below. So that's kind of what's been so far, and then kind of looking ahead a bit. The heat network market framework is currently going through kind of reviews and updates, consultations in government, and the end goal of that is that heat networks are set to become the fifth utility. That's expected to kind of come into place around about 2025-ish, with Ofgem kind of covering that as the regulator. That framework is going to cover all sorts of things. The two key ones to note are customer protection. So in the ways that customers are protected with kind of water, gas, electricity, the same things will start to apply to heat as well. And also the kind of the assurance mechanisms are going to become kind of no longer just good practice requirements, but also legal requirements. And that's going to be as part of assurance schemes as part of this framework. And it's currently looking like CP1 will form the technical framework for the market framework. So what are currently CP1 assurance requirements will in the future kind of likely become legal compliance and assurance requirements. So that's the lie of the land kind of in the industry. And so before we dive into the actual kind of assurance mechanisms, I think it's good to frame this by saying that high performing heat networks are definitely achievable. So this is an example of a scheme that we worked on a few years ago now. The blue line at the top shows the flow temperature, and the green line at the bottom shows return temperature. And what you're looking for ideally is a kind of a stable flow temperature, kind of as low as possible. So we've got 60 degrees here, and then a return temperature kind of around the 30-degree mark, and you'll see some slight variance with seasons. What we have seen, and what was kind of some typical issues with heat networks going is that the flow temperature will be higher and will also be variable. So kind of issues with control in the energy center. Then the return temperature would also be much higher than we can see here, and kind of closer to what the flow temperatures. So in addition to high performance, there's also several other benefits to assurance and to kind of ensuring that your heat networks are delivered kind of performing well, and those are proven capex reduction. So a good example of this is pipe sizing. If you can size your pipes accurately, then not only are you reducing capex, but you're also improving performance by reducing heat losses. You're also significantly reducing your risk, and this is kind of all sorts of types of risk. So it's kind of compliance with building regulations, it's kind of security of supply of heat, it's resident complaints, resident comfort, and then also you're kind of, as the graph on the previous slide is one of several sites we've worked on recently which have been handed over performing well, and that performance we've seen kind of maintained over several years now, and that also means that the resident experience is greatly improved. So we've had feedback from housing associations, especially that the complaints on schemes that have been through the assurance process are kind of 95% lower than what you'd see on schemes that haven't been through that process. And also throughout the process of both in kind of in new build and on kind of operation side, working with the assurance process helps to kind of upskill the market, and kind of hopefully the end goal of that is to kind of increase the maturity, the skill levels, and also kind of the motivation of, do you hand one scheme over well, that's performing well, you're going to want to go do that again. You want to go beat what you did last time. The three key messages that I'd like to everyone to kind of keep in mind throughout this is that number one is that the collaboration is absolutely vital. There are kind of heat networks are very complicated, lots of moving parts, lots of stakeholders, and this process will only work if everyone is pulling in the right direction. Second message is also that so measuring and verifying performance is absolutely crucial. So it's kind of the trust that verify process. Kind of you have to trust that everyone who's playing a part in delivering these networks are going to do their job well, but also verifying that, and the easiest way to do that is through data, and that's whether it's heat meter data of your from remote monitoring, or also remote access to the BMS, and that data is really it's how it's how you can prove that your network is performing well, and also how you're meeting those the key kind of performance in kind of the KPIs that are laid out in CP1. And thirdly is that it's all about process. Kind of the aim is to have a process in place that is transparent, that is consistent, and that is kind of repeatable, because that it makes it much easier for all parties to understand, and makes buy-in much easier, and it also makes it much easier once you get into repeat business. It makes it much easier to understand what's going on and improve practices and processes, and with the end goal of improving the end performance of your heat networks. So looking into design, so the way our key assurance document in the design stage is our design supplement, and this is it's a guide to use CP1. Rather, it's not a replacement. It's just it helps to kind of fill in the blanks and provide designers with kind of sets of core principles, kind of key client requirements, and also lays out kind of a few more of those KPIs and key objectives for heat networks, and also provides clear measurement verification processes. This is now in process for about over 20 organizations in about 20,000 homes per year, And also this is kind of forms the cornerstone of the peer review process that we go through with designs through kind of stage 2 all the way to stage 4. Once you start getting on site and once you start your construction process, the first stage is the kind of the contractor design. So that's kind of looking at technical submittals, kind of underfloor heating designs, pipework expansion designs, that kind of thing. And the aims here are to kind of introduce the contractor to the scheme, to the design, to its kind of its quirks and to its kind of specifics, and kind of make sure that the equipment that gets proposed and the kind of the updated designs that get proposed are in line with all the hard work that's been done through the design process, and that equipment's being, that the equipment that's being chosen is actually going to work and is going to deliver a scheme that works. So an example of this is, say for example, you've gone through your pipe sizing exercise during your stage 4 design, and you've selected a specific HOU. It's been through the beta test with proven low return temperatures, and you've been able to size your pipes based on those assumptions and kind of look for large delta T and low flow rates to help you really minimize those pipework sizes. And then when you get to the tech subs, so if you kind of the contractor proposes an alternative HOU, it may offer some reduction in cost to the client, but if the return temperatures of this unit are not quite as good as the original unit, then the flow rate's going to be higher, and the impact of that's that the pipeworks are potentially undersized. So whilst you'd have a capex saving, the risk is much increased, and you're potentially going to have some serious issues meeting your peak demands in operation. So the kind of our role there is to kind of to make that connection and to advise the contractor that this unit isn't going to work with the rest of the design, and then work with them to kind of come to a solution that works with everything else, kind of and all the other moving parts within the heat network. And once you get on site, kind of we've at this stage, spent a long time getting all the design, all the drawings, getting those all agreed. We need to make sure that what's on the drawings actually goes in and kind of gets installed as it's been designed. And so our role here, and the assurance role here, is to sort of we'd go review installation both throughout the network, the plant room, and then we're also looking at insulation standards as well. So again, looking at that throughout the entire system. And kind of the aim here is to both we're checking that the valves are in the right place, heat meters are all in the right place, but it's not just does the install match the schematic. We're also looking at the specifics of install that you can't catch in a specification or in a schematic. So things like are the isolation valves located in a position where can you access the valve and can the handle move the full 90 degrees, as an example? Because if that can't happen, then the valve may as well not be there, or it's kind of, is the heat meter located within the required straight lengths of pipe upstream so that the data you get is reliable, and so that you can accurately go review your KPIs once you come to handing over the scheme. And from the insulation side, it's there's the rule of thumb that 1 meter of uninsulated pipe will give you an equivalent amount of heat loss to 10 meters of insulated pipe. So whilst only it may only be a small amount, what kind of we're there to kind of help work with people on site and kind of find the solution to maximize the insulation coverage, reduce coordination clashes, to make sure that we can really push those heat losses down. Again, with the bearing in mind the KPIs we agreed back at the project inception, that the contractor or the insulation subcontractor is likely not aware of. we get to the commissioning process, I think this is essentially my favorite part of the project delivery part. This is where where things get really interesting, and you're taking a static installed system, so you're taking a bunch of pipe, bunch of equipment that's just sat idle, and you're filling your system, flushing it, and then taking it from empty and not running to an operational dynamic system that can operate from your minimum to your maximum demand. This kind of previously or kind of historically has been, it's kind of an exercise of making sure that your boilers get commissioned, your pumps get commissioned, your pressurization unit gets commissioned, your HOUs get commissioned, but that a majority of that will happen in isolation. And when you see unstable flow temperatures, that is historically or is typically due to no one having done the checks during the commissioning phase of how does all of this equipment work in unison together. When there's an increase in demand, do additional boilers come on? Are they operating as was intended during the DESOPs? Are the pumps, are they looking at all of their index run sensors? Are they ramping up and down? Are there any bypasses left open on the system which are potentially starving parts of the network for heat and for flow? And also it's not just the performance side, you're also then looking from a risk point of view and from a kind of a fault point of view. So say you have a piece of equipment that has quite a has a lower pressure rating than everything else, that's potentially the risk or the lowest point of failure. Are the relevant alarms in place? Would do the pumps turn off when they're meant to? If you hit the emergency knock-off button, if there's an emergency, does everything turn off, or do things keep running? So it's there's a performance element to it, but you're also making sure that the system is safe to operate, kind of both for your operatives, kind of the O&M contractor, but then also from an equipment and a premature failure point of view, and then also from a kind of a resident risk to residents as well. And one, I suppose, in addition to equipment, you're also then looking at water quality as well. And this has been a bit of a sleeping giant in the heat network industry over the last few years, where kind of historically not loads of attention has been paid to water treatment, but we're starting to realize the impacts of that now, where kind of you're hearing schemes where the entire network is you're seeing pinhole leaks on the network on schemes which are 2-3 years old. So this very expensive and complicated asset, after 2-3 years you're going in and having to replace the entire network, which is very expensive, and also for the residents on that scheme is a significant upheaval and a significant inconvenience for them. So the way with water treatment, the way there's a lot of upfront kind of discussion. This really has to be a kind of a collaboration both with the contractor and also with their specialists as well. So you're looking to get a process agreed upfront, prior to any water entering the system, and then once there is, once you've gone through your flushing process, you're looking to it's all about the detail here. There really is no substitute for kind of being kind of thorough and detail oriented. So this, for example, shows a water quality trend tracker. This is just one point of sampling. This is one of will be one of several for a site. If you, for example, if you have 2-3 hydraulic circuits on your system, this very easily could be one of 15-16 samples that you need to be monitoring, and every 2 weeks to keep on top of your quality. And this is just one sample for 3-4 months. So the amount of data you collect is really quite vast. And our role here, and kind of where our aims within our role during the water treatment process, is to help the contractor kind of make sure that the data all the data we need is coming through, that we have an evidence base that is thorough and that is shows either if water quality is good, or for example if things are going bad. So if you look at for example the iron levels in the on the top row, second in from the right, you can see that from when the trend started, we've had decreasing iron levels, which is good, so we'd be feeding back this is good, iron's going down. But then there's one sample where something has happened in the system and the iron goes up again. So at this point we'd be looking to we'd be raising this and say we spotted something in the trends, have you seen this, and then as what are the potential causes of this, and then what can we do to reverse this trend and bring it back in the direction that we want to. Then you can see here for the iron that the interventions there worked, but then if you look at the copper levels, which is in the middle row, second in, you can see that the initial intervention worked for the copper, but then something else has happened later down the line and the copper levels have jumped up again. So it's either the initial solution hasn't solved the issue, or there's something else going on. So then we'd be going back back to the table, saying what can we do differently, what else can we do to try and bring this back in line. And Ivan is going to, in his presentation, is going to go through and really talk about kind of what can happen if you don't do this, and the kind of potential impacts to your pipework and to the chemistry of the system. And so the final role in when you're on site during the construction and commissioning process is validation of commissioning of your HAUs and of your end units. There's only one plant room, but you have potentially several hundred of these HAUs on a scheme, and it only takes one or two of these to be performing poorly to completely throw off your return temperatures. One we've seen on schemes where, for example, we've had a 100 unit scheme with a where the return temperature was elevated, and we went through the data. Again, going back to the having access to data being important, we went through the data, located one HAU that was bypassing, closed it, and 20 degrees dropped from the return temperature within the space of 20 minutes. So it really is important that not only you're validating commissioning of your HAUs, but also that you're doing it for every single HAU. There is no kind of, it has to be 100% here, because it only takes one, and if you only do 80%, it's the one problem flat is, well, the way things work, it's always going to be in the 20% you haven't been into. So our testing role, it looks at, so we have four checks. So what we're trying to do here is make sure that the unit's performing efficiently and performing in a way that will deliver reliable service to the resident in all modes of its operation. So the first check is all the install and is the installation all correct? So is the HAU installation box, is that all intact? Is the pipework above the HAU insulated well? The terminal runs can make up 50% of the total network length. So those couple of meters above the HAU, making sure the insulation there is good and up to standard with the rest of the network has a huge impact on your overall losses and in meeting those KPIs that you set out back when specifying the network. Then you'll check the HAU during standby mode, so you're looking with no load on, no hot water, no heating. Is the unit bypassing? Is there anything strange going on? Is it operating as it should be, as the testing and previous operational data shows it should be? And you're testing that in line with the hot water performance. So are the delivery times within the agreed criteria, and are they low enough to ensure that the resident is going to be happy and have the perception of water getting hot quickly. You're also then looking at the space heating. So, when it gets cold outside, residents will want, you need to make sure that the flats get hot, but you need to make sure that that's done in conjunction with ensuring that that doesn't impact network performance. So we'd go through, check that the temperatures coming out of the HAU are correct going into either your underfloor or your radiators. And then also you're checking the balancing of each of your loops or each of your radiators to ensure that the return temperature coming back to the unit is low and is kind of as designed to make sure that the return temperatures on the network during your winter months are stay low as well. And this is something we've been doing for 5-6 years now since the company's inception. I think we're on over 5,000 flats tested and passed during the process. And this is something that during the consultation for the updates to CP1, we spoke to CIBSE and to the steering committee about it, and this has now been incorporated as a key, one of the cornerstone assurance minimum requirements for heat networks going forwards. And Paul's going to talk about in his presentation a bit more about the kind of the client's perspective of what going through the acceptance testing process on site means from that point of view. And to finish off, so going back to our initial graph, if you go through those steps, those assurance steps, well-performing networks are not only achievable, they're also definitely repeatable. So this is going back to the same scheme we had at the start, and I don't know if you spotted the year on those, but this is a year later, and you can see that the trend is exactly the same. But you really need to have that assurance role in throughout the entire process of your heat network from kind of inception to handover, because these systems are so complicated and because there are so many moving parts. It only takes one of these to go wrong for it to have a significant impact on the final performance when you hand over. So the key takeaways. So again, collaboration is key. In my experience, this role and this kind of what we do has worked so much better when you get engagement from all of your stakeholders. That's everyone that's involved in the heat network from the moment it starts to the moment it gets handed over, and kind of also then throughout the entire operational phase. If people are are willing and are kind of engaged and motivated to maximize performance and to kind of minimize risk, then you end up with a much smoother process, and then you also will end up with better performing systems as well. So number 2, going back to the measuring, verifying performance, this being able to measure your performance and being able to verify that the system is operating as designed and as specified at the moment of handover de-risks everyone's position. That's proof that the scheme's been designed well, proof it's been constructed, commissioned well, proof that it's going to operate well, and also also for us as well, proof that it's been assured well as well. And again, just to finish off, this is all about process. It's an open and consistent and transparent process makes it much easier to buy in, makes it much easier to understand, and also makes it much easier to repeat consistently across sites. And that's also why we see any stakeholder throughout this process that we've worked with on multiple occasions. It's evident the improvement in quality that at the end goal that is delivered. Yeah, I think that's everything for me. Thank you for listening, and I'll pass over to Paul to talk about quality assurance from a developer's perspective.
Thanks, Tom. Okay, so a little bit about me. I'm Paul from Telford Homes. I deal predominantly with the M&E installs across most of our jobs, and one of the main things at Telford's, we do take considerable pride in our product in terms of everything really, so aesthetics, efficiency, customer comfort, and as part of that, we've been working with FairHeat over a number of years now, and this has resulted in improving our efficiencies across the board. So that's in terms of design, installation, and system performance, as the guys mentioned previously. A key part of our performance improvements has been the adoption of acceptance testing. We now adopt that as a mandatory requirement across all of our commissioning processes. So this is no different in our mind to the electrical commissioning, HR commissioning, MEVs, anything like that. It's one of the requirements we have before we hand anything over. This to date, we've done approximately 3,000 units. We've got another 7 sites coming up, which is another 4,000 units, and each one of those units will be acceptance test passed, and we aim for 100% passing of these units. We don't do batch testing. So that is just a little snippet of how we like to perform as a company. Part of this process, we incorporate this into our own construction procedures. So there's a dedicated QA performance sheet that we've created in conjunction with FairHeat. So this form will effectively detail the process from start to finish, every item of requirement, and this is then issued to our subcontractor, who will effectively tick sheet it to say that he's done it as per the acceptance testing criteria, which is developed early on in the process. When we start this project, we tend to do batch visits from FairHeat. So while we review the criteria, we'll get them back here and we'll say, all right, we've got 10 plots here. We want you to witness this, to witness that. So what we tend to do is agree the criteria first and foremost. We then offer FairHeat to come to site in line with normally our consultants and our mechanical contractors, and we'll walk the criteria. So, I mean, as many of you guys probably know, with the best will in the world, we can design everything on paper, and in reality, some things may change. So as Tom alluded to earlier, there's certain instances where we may need a reduction in insulation, we may need to slightly shift the pipe route, something like that. And that is part of the collaboration that the guys are talking about. So we all engage early on, we discuss these items, and we close them out so we make sure that what we actually install when we go full head is as per either the initial requirements or the revised requirements. And this has now, we now develop this in line with the latest best practice, as the guys mentioned before, revised CP1, and everyone is on board with this from day one. I think the guys will, as I mentioned earlier, and probably Orchard previously, we used them. Everyone will agree that this is something we like to do, and it makes the process a lot easier. It avoids revisits that none of us like. It means everyone knows where we stand. There's no second guessing. There's no grey areas. It's a very clear process. We also do this I mean, it's not exactly acceptance testing for the plots, but we do this in regards to the whole network. So we do, as Tom mentioned, the network installation, the plant rooms, the load tests, everything is fully detailed. All the data's come back, it's assessed, and we ensure our systems comply fully with the designs. From a contractor's development perspective, it's proved monumental from what we're doing. I mean, only 2 years ago, this process was proving difficult. It was, I suppose it's an education process for everyone involved. So we have now adopted it. Our contractors know what we expect, and it's, as Tom mentioned earlier, it's very easy to achieve these results if you buy in early on. It's not anything overly complicated now. So we're very grateful for the time that we've got with our contractors, our consultants, FairHeat as well, and the buy-in we've got from everyone across the board. This is also, I mean, I don't know if we've mentioned this before, but this is also something we're finding is very beneficial with regards to ESCOs and the growing involvement in ESCOs. I know Tom mentioned that this is vastly becoming the utility, and there will be more of a requirement going forward. But with this acceptance testing being adopted across the board, it makes the adoption process a lot easier with regards to ESCOs, because we have validated that we have achieved the criteria and we are where we need to be with regards to any design criteria that may come up, and any requirements specifically to the ESCOs that may supersede our design criteria, which will be engaged on early on. So I mean, in summary, this is just wanted to say that this is something that we do across the board. We are extremely happy with where we're achieving now, and I'm sure the guys will not mind me saying that we're grateful to both the contractors and FairHeat for helping us get to this point. And we're looking forward to improving every day, because every time you get a job, it's only one way to go, and that's more improvement. Cheers, Tom.
Thanks for that, Paul. Now I'll move on to Ivan, if you'd like to talk about your experience from a contractor's point of view and the role of water treatment.
Okay, thank you, Tom. Right, so let's start off with the importance of water treatment, specifically in closed-loop heating systems. If we can have the next slide, please, Tom. Right, so what is water treatment? This is simply defined as any process that improves the quality of water to make it appropriate for specific end use. This end use can be anything from drinking water to irrigation to water recreation, or the safe return of water back into the environment. Next slide, please, Tom. Right, so water treatment in the built environment. So historically, we know that when a heating system is filled with raw water, we are faced with 4 problems. First one being corrosion, scale formation, microbiological growth, and fouling. Next slide, please, Tom. Let's have a look. What is corrosion? So corrosion is the reaction of a metal with its environment to return to a stable, low energy state. It is a natural process which will always occur if the correct conditions are present. So we are faced with 3 main processes of corrosion, these being oxygen, galvanic, and pH facilitated. The effects of these types of corrosion will destroy system metals, reduce heat transfer efficiencies, create leaks in equipment, and increase operational costs. Next slide, please. Right, so we have some examples of those 3 types of corrosion. The top left hand is a pH facilitated corrosion of aluminium, where the aluminium oxide, which is its natural corrosion protection, has been stripped back. We will find this usually in pH range, anything up to 4.5 and anything above 8.5. The next image is galvanic corrosion, which is a mixture of dissimilar metals, where your noble metal will cause a reaction with your less noble metal, and you'll have corrosion formation. A big issue we find nowadays is oxygen corrosion of iron, which is your third image. What we see here is the corrosion of a black iron pipework, which has basically corroded within a short space of time due to oxygen ingress. Next slide, please, Tom. Right, scale formation. So scale is the deposition of sparingly soluble compounds as hard crystalline deposits in heat exchange surfaces and pipework. This type of scale is normally formed from calcium carbonates, and a good example is the scale normally found in kettles. When scale is allowed to build up inside pipes, the resistance to heat transfer increases cumulatively. This means that as the system becomes more inefficient, it takes increasing energy to heat water in the foul pipes. This leads to energy wastage and failure of high valuable plant and equipment. Next image, please, Tom. Right, so we've got some examples of scale formation. The first image is a stainless steel HIU plate, which is 100% scaled up, and you have no throughput of water. The second is a cross-section of a boiler tube, which has scaled up to a point of failure. The third image is scale formed inside copper pipes on a domestic hot water cylinder. The table at the bottom which gives you a comparison of scale thickness to heat loss and loss in heat transfer. And as you can see, at 0.3 moles of scale, you have a 21% loss in heat transfer. So it doesn't take a lot of scale for you to start to see massive wastage of energy and increased costs in running. Next slide, please, Tom. Okay, microbial growth. This is the growth of numerous individual microorganisms to the extent that they form masses of cells called biofilm. Now, biofilm is a thermal insulator which can interfere with heat transfer across a metal surface. What is interesting is that biofilm is 4 times better at preventing heat transfer than scale. And in addition to affecting heat transfer, some microorganisms have the potential of causing serious problems like system blockages, strainers, heat exchangers, control valves, reduce system efficiencies through thermal insulation across plates, accelerated corrosion across all metal surfaces, and poor commissioning data. And this is caused usually by bacterial gases, which affect the data and then lead to poor configured systems. Next slide, please, Tom. So what we have on this picture is a really good example of, in essence, what biofilm is. And what you see, it's a gelatinous sort of material which protects your bacteria from removal by biocides. So in essence, what you want is you want to ensure that you don't get to a stage with biofilm, because it is one of the hardest, if not sometimes impossible, to remove from a heating system. Next slide, please, Tom. Fouling. Right, so fouling is the accumulation of suspended matter, usually as loose deposits, and these will once again interfere with heat transfer and fluid flow. The effects of fouling: you have reduced heat transfer efficiencies, decreased fluid flow, increased system pressures, interference with commissioning data, and increases in operational costs. Next slide, please, Tom. So, in closing, water treatment is important because improper water treatment or no water treatment at all will increase energy consumption and operating costs while decreasing your mechanical equipment efficiencies and life expectancy. So in a nutshell, regardless of how technologically advanced your system is, if your hydraulic system, which is the water, is not correct, the rest is irrelevant. Thank you, Tom. That's the presentation.
Thanks, Ivan, and thanks, Ricky, as well, and Paul and Tom for your presentations there. So yeah, we're just going to move on to the Q&A now. If you do have any questions, please do put them into the chat. We have some predetermined questions that we're going to run through. So if the speakers would just like to kind of unmute themselves and put their cameras on, we can run through them. But I think firstly, to Tom, obviously at FairHeat, what have been the challenges, I guess, of being a third-party witnesser in this process, and where has it gone well, and why do you think it has gone well?
I think I suppose the main thing that surprised me was really, I when I came into this role, like, everyone talks a lot about the technical side of it, and how low carbon, high efficiency, all sounds great. What no one tells you is that actually, turning that theory into reality is kind of potentially more about kind of the relationships you build and the ways you work with people kind of throughout the life of a heat network. And kind of you can have all the technical knowledge in the world, but if you just if nobody likes you, and if no one's willing to work with you, then it counts for nothing. So the schemes, the best networks have been, it's always been how how well are you working with, it's the people on site, it's your contractors, project managers, then also all the other people as well. So your equipment manufacturers, it's the consultants, it's various people throughout the developers, developers teams. That is I think has been the key takeaway for me, is that it's that is should be a main focus for everyone, in terms of improving performance and kind of ensuring that people are working well and kind of pull in the same way.
Great, thanks, Tom. And just kind of putting a similar question over to you, Paul. Kind of what has been your experience of having the third-party witnesser in what is probably an already challenging process with lots of different stakeholders, and how has that impacted your relationship with the stakeholders in the process?
Yeah, I mean, I think as Tom mentioned there, the collaboration is key early on. I think initially, without that, it can prove challenging, having a third party who's not on site all the time, interfacing with guys on site all the time. The relationship's not there. It's hard to get certain things implemented. But as we like to collaborate early on, obviously we get this process ironed out a lot early on in the project. So I would say now, with this collaboration, it's a good process, a positive process. I don't see any issues with anything we've done so far. I think everyone sees the improvement now. It's very open book. So I think even with our other stakeholders, our contractors, our site teams, yourselves, it's open book from day one. We know what we expect. We know what to achieve. We have our benchmark visits, and there's no grey areas coming through. So when we actually get through to the full acceptance testing process, it is a positive experience. And everyone likes a green tick next to their name anyway. So when we start getting those pass rates up, it does perk people up a bit.
Thanks, Paul. And yeah, coming to you guys at Orchard, I guess putting the question to you as well, like how has your experience been from the mechanical contractor's perspective of having third-party witnesses involved?
Well, initially it's been tough. Obviously upskilling our workforce to adapt, especially through the criteria testing, but like we've mentioned a few times tonight, making sure we're all happy with the design, not just from a mechanical point of view, but also from an install point of view. Once we're happy with that, then just working through and then building on everything throughout the project. Agreeing the criteria as well for the design parameters at the beginning, so we all know and we're happy with what we're going to be checking and installing to. Making sure we allow the correct time throughout the project is always key. Making sure we book FairHeat in the right times and the right areas to make the install and meet Telford's or wherever the contractor's program is. That's always a key and a pinch point sometimes, but once you've done one or two sites and 1 or 2 days with them, we soon get used to it and we'll work together, and lots of talking is the key, I'd say.
Yeah, definitely. And I think just going back to Ivan's presentation on water quality, I think you guys had quite a positive experience at one of your sites with the QA on water quality and ensuring that the water quality was of high quality. I think at Guardians maybe.
Yeah, no, absolutely. I think what is really critical is that from the beginning, as it's been mentioned, the criteria has to be set and then the process has to be followed. And I think the only way that you can ensure the process is being followed is by having a third party come in and validate your process to ensure that you are achieving your targets and your set parameters are where they should be. I mean, in the real ideal world, no one is perfect. We do have occasions where you'll have someone who'll drop the ball. And I think having a third party like FairHeat who needs to verify every process, that if we should miss something, 100% FairHeat won't miss it. And obviously raise the issue, and then we'll be able to then address it. So I think, initially it was really hard having a third party telling you how to do your job. Absolutely. but I think working with FairHeat has ensured that when we do hand a project over, we can 100% be satisfied that we will not be called back for any aspect of our job, because we know it's been done right and the processes have been followed.
Great, thanks, Ivan. Next question, Tom. I think, what do you think are the key tools required to do the role of the quality assurer and the third-party witnesser?
I think the number one by quite a long way is as much data as you can get. There's no. I don't think there's no such thing as too much data, and again, because it's very difficult to, or it can be difficult to kind of be stood in a plant room and work out what's going wrong. Everything's happening inside. You can't see the water moving around. You can't. All you're doing is reading heat meters and reading BMS panels. So it's being able to trend that and being able to kind of review and look at your performance over kind of days and weeks just makes everything so much clearer. And kind of heat meter data as well from kind of your HOUs is being able to pinpoint where that bypass is, or kind of where the hot water set point's too high, and it's that is kind of without that information you are running blind, and it's a lot more time consuming, and it's potentially the end resolutions aren't as good.
Thanks, Tom. Next question to both Paul and Ivan and Ricky, I think. Has working with kind of the third party and collaborating with the likes of FairHeat, has that changed your organisation's perspective on heat networks at all?
I'll jump in first. Yeah, I mean, from Telford's perspective, it has changed it massively. From a construction perspective, irrespective of company, I know the main element to a job is to get heat on, and historically that was key. Heat on, great, crack on, close the door, all we go. But now I would say it's opened our eyes a lot more to what is achievable and what can be done, savings to be had as well. I mean, not just sustainability wise, but also commercially, and it does work to do it this way. So yeah, I'll just say it's been an eye-opening experience, and obviously looking forward to carrying on. And where we're at now is miles ahead of where we were even a couple of years ago. So we're moving in the right direction, definitely.
Yeah, for me, it's the big one for us is because things or the systems are getting checked to such a high standard. It's the trust in the system once it's handed over. So if we do get any calls, we then haven't got to go back to basics and checking every single aspect of what potentially could be wrong in the system, because it's already been checked to such a high standard. We can then review, and we've got a better outlook on what could potentially be the risks rather than starting right back at scratch. And also we have it's a nice place to be in. If there is a problem with the heating or there is a callback, we know that it was originally tested to a high standard. So we know it will be a basic general defect. It might be someone hasn't got credit on their meter. And obviously something like Guru can check that anyway remotely and save a lot of wasted visits to people's houses.
Great, thanks guys. We have had a question come through from the audience. So this is a message to Tom. Prior to 2020, this is from Paul Alcock, we had a discussion about 5th generation heat networks. How has the market adapted to take on 5th generation rather than keeping with the tried and tested 4th generation?
I think when 5th generation first started, first came on scene, it was quite a hot topic, and there was a lot of, there was an initial kind of there was a lot of talk about putting it, completely everywhere. I was kind of, let's, don't worry about 4th. Let's, this is new, this is shiny. Let's go, let's go. But I think that kind of equilibrium points shifted back a bit more. I think the more people have looked into the 5th generation, kind of the ambient systems, they realise that they definitely have use, and there are instances where that may be the optimal solution, but also when you compare it to Forth and when you actually stack the numbers up, especially in London and other high density areas like this where it's predominantly heating that you're looking for, there's fourth generation is not only more efficient, but it's also you're future proofing as well, because you have these larger district schemes coming through. It's you're building something that in the future is going to be much easier to decarbonize as well. So we've definitely seen, whilst there's been a lot of talk about it, actually within London, in our experience on the schemes we've worked on, there aren't that many schemes which are actually coming through and which have chosen fifth generation as their preferred energy strategy when push comes to shove, essentially.
Great, thanks, Tom. And just a kind of another question to you, and about fourth generation, but what do you think the benefits are to the end user of having quite a rigorous QA process throughout the whole construction and commissioning?
It's assurance for the resident as well, that you're being delivered a system that has been checked checked as much as it can be, and that therefore it's going to operate in the way it should be. Ideally, the residents' perception of the heating and hot water is that it's there. If you don't have to think about it, then we've done our job very well. And then the additional benefit is feedback we've had from housing associations, from their their liaison officers, is that knowledge that you're on a scheme that is efficient and that is low carbon, helps people feel like they're doing their bit and being living a more sustainable life.
Great, thanks. Well, we've hit 7 o'clock, which is when we said we'd end. We've got through most of the questions, so I think we'll probably leave it there. The meeting has been recorded and it will go up onto the CIBSE YouTube channel, I think. So please feel free to watch it back at a later date, or share with people who you think might find it interesting. But I just want to say huge thank you to all our speakers who've joined us today, and also thank you to everyone else who has joined and participated in this. And if you want any more information, please feel free to get in contact with the YPG and we can forward you on to whoever. But yeah, thanks everyone.
Thanks, guys.
Cool.
Cheers.
Thanks,
Thank you.
everyone.